Welcome back to Offworld, the show where we talk about all things space exploration and pop culture. I'm Ariel Waldman.
And I'm Norm Chan. If you're watching the video today, you may notice that we're not in our traditional studio. We're actually recording on location at NASA Ames Research Park.
Yeah, NASA Ames Research Center. And we're actually in the visitor center. NASA is just so awesome. But it's really awesome to have a NASA center in our own backyard and be here. We're actually talking about A Trip to the Moon, the 1902 film about going to the moon, which is actually really amazing in all the things that it depicts. You know, it's a 14-minute film, but I was amazed to finally watch it from beginning to end and really be impressed with just everything that they show.
A lot of people might recognize the iconography from the film of the bullet hitting the face of the moon. That's probably the most recognized imagery, but it was maybe the first science fiction film ever done over 100 years ago by George Méliès, and it depicted a trip of astronauts to what they thought would be the moon's surface. Now, who better to talk about what's actually on the moon's surface and what we know about the moon than your guest today, NASA scientist. So let's go hear the conversation.
Yep. So today we're talking about A Trip to the Moon, which is this adorable, awesome 1902 film. I'm so glad you both watched it because you're both moon geeks is sort of how I would think of you both. Kimberly, please go ahead and introduce yourself and say a bit about what you work on.
Dr. Kimberly Ennico Smith. I'm actually a research astrophysicist here at NASA Ames Research Center in Silicon Valley, California. But I have been working on the moon, and I've also worked on the Pluto flyby mission. So I'm an astrophysicist of many trades, attracted to interesting questions and the space missions to deliver answers to those questions.
Awesome. I'm so excited to have you here. Tony, please introduce yourself and a bit about what you do.
Sure. I'm Tony Colaprete. I'm also here at NASA Ames. I'm a planetary scientist, which means I study various aspects of planetary bodies. My background is in atmospheres, mostly, clouds and microphysics and climate. But by chance, I got into studying the moon as well about 15 years ago or so, and have worked on several lunar missions, the L-Cross mission, the LADEE mission, and am now building instruments that are going on the commercial landers coming up.
That's pretty awesome. Yeah, so I wanted to ask you both about like what moon missions you've worked on or are working on. Can you explain like a little bit about some of the ones that you've been on?
Yeah, and actually Kim and I were both on L-Cross, the Lunar Crater Reconnaissance Observation Sensing Satellite.
You know, NASA likes to make acronyms.
Long acronyms.
I do remember L-Cross.
Acronyms.
And that's a forced acronym.
That was a very forced
acronym. But that was my first lunar mission. Was that your first lunar mission?
That was my first lunar mission.
Yeah.
And as an astronomer, whenever I get time on my telescopes, I would always ask for time when the moon wasn't up.
Yeah, curse the moon.
And so when I joined the L-Cross mission, which was a fantastic experience where they were going after a question, and it was a different take on doing space missions, I was just totally attracted and became a moon lover ever since.
Yeah, and so the L-Cross mission, it was an impactor, like 2009, sent to the moon, and to impact and kick up all of that soil, right? To like see if there's water ice.
Exactly. We understood there was hydrogen there, but we didn't know the form of the hydrogen. Was it water ice? Was it just protons in the soil, or was it hydrated minerals? And so the L-Cross mission was a very targeted, strategic mission to understand the form and the quantity, at least in one location. And it was done in a very short time frame. It was the entire mission from concept to finale was about 28 months, which is very quick. It was right along with the Lunar Reconnaissance Orbiter, which is still orbiting the moon now, 10 years later. It's coming on our anniversary. So that was, Kim led the instrument development. I was the lead scientist. And
we were doing a lot of new things as well.
A lot of new things.
I mean, we were taking commercial off-the-shelf cameras and spectrometers, things that, my previous experience we'd never do. But we space-readied them. We made them sure they would survive, and they were able to deliver the mission. And I like to think of L-Cross as a perfect example of the scientific method. There was the question. The previous mission had noticed that there was hydrogen excesses at both poles. No one knew why. The question that L-Cross was going to answer was the hydrogen in the form of water. Then you design the experiment. You can design it so many different ways. The choice was this impactor. You slammed into the moon, excavated, but you needed the right instruments to make the measurements. and used a spectrometer to measure, spread the light over different wavelengths, was able to identify the molecules of which water was in the form of water ice.
Yeah.
And then, answered that questions and answered a whole bunch more, because the spectra also revealed that the bottom of that crater that we hit was full of other things as well.
Yeah.
Yeah.
And so, the questions keep coming.
I know. So this is what I love so much about the moon in general, is kind of our history of knowledge, of learning different things over time. So we all watched A Trip to the Moon. What was like your favorite thing that you saw depicted, or what did you enjoy seeing depicted in this film that's from now so long ago, before we had even touched the moon?
And it's before we even had the first airplane. The Wright brothers didn't fly until 1903, which was a year after this film had come out, even though there's some groups working on heavier than air flight. But talk about that visionary, doing the trip to the moon. That's what stunned me, is that the imagination and also some interesting physics was put in mind. They had the cannon with a bullet.
Yeah.
So they knew they had to accelerate their, crew capsule to leave the Earth's gravity, and so they were using what their knowledge at the time.
And along those same lines, I really like the return.
Yeah.
They just fell over the edge of the moon
Yes.
to Earth.
Yes.
But they splashed down in the ocean, just
Yeah.
like we did Apollo, and plan to do future missions. So
Yeah. Were there any other aspects that you found sort of like delightful as you were watching the
Oh,
film?
I love the caverns, because we now
Yeah.
know there are collapsed lava tubes and skylights on the moon, and many people are very interested in exploring them, just like they did. I don't think we'll find mushrooms
Yes,
or
maybe
the
no
selenites. Is that you?
The
did
selenites were the
that-
moon people.
Moon people, and I particularly like the lack of biological contamination control when they accidentally brought a selenite back on the back of the spacecraft. That's something at NASA we are very, very always worried about and concerned about, especially with trips to like Mars, where we're looking for life, potential life, or ancient life. Is you want to avoid cross-contamination. They did that with the Apollo program. They came back, they're in quarantine. No quarantine here. They just kind of ran around and captured the selenite and at the end. But it was a mix of, wow, that was kind of an accurate prediction, and then the fanciful parts that put it all together. So I watched it with my kids, and that was really fun to see how my kids looked at it and saw it the same way I did. I think, like, wow, this is really kind of entertaining. And in some ways very factual, in other ways, really they thought it would snow. Yeah, on the moon.
Fantastical.
Yeah, fantastical.
There was one scene that I thought was quite amusing, is when the astronomers, of course, it's interesting that the folks going to the moon are astronomers, and they're walking through the shop and they're seeing all the people behind the scenes who were making the spacecraft. They're there with that Victorian era can-do attitude, knocking on the metal and the cranes and everything like that, putting together, and then they're all thanking each other, because the same with any of these missions, it's not just the astronauts or the people in the limelight. There's a lot of people behind the scenes that make these things happen. And so there's one area where, that's true. So if you're looking at a mission today, whether it's robotic or human, there's a lot of people behind the scenes to make it happen. Building that capsule, testing that capsule, making the instruments work, making sure the calibration of the instruments works, analyzing the data, doing the navigation, doing the trajectory.
Yeah.
That was quite fun to see.
Yeah. Well, and also they brought umbrellas with them, which I kind of enjoyed from the perspective of, thanks to L-Cross and some other missions, like we now know there's water on the moon, right? Yeah. And I even saw a headline go by the other day that was like, it rains on the moon, because if you take into account when meteorites, hit the moon, maybe they kick up some water ice or something. It was definitely like a strained version of rain.
There's a scene in the film about how it's snowing on the moon. Now, it's curious why the director wanted to show that aspect, but one could imagine a big meteor storm happening and colliding with the moon. And Tony worked on another lunar mission called Laddie, which had made these measurements of what happens to the lunar atmosphere when it gets hit during what we call meteor showers. If we see wonderful falling stars, which are pieces of rock burning up in our atmosphere, the moon is also experiencing that as well. We're in the same region of space. And
now that you mention that, I want to go back and look at that scene, because right before it rained, there was all the celestial activity. There were stars out or something like that, right, with the faces in it.
The faces in it, they had these,
and then it started to snow. So I like that comparison to micrometeoroids raining down and creating a rain of their own. on the lunar surface,
Yeah.
including dust. There's a lot of activity that can occur with the dust and the electrostatic charging nearby. And this mission Laddie, was able to detect the ejecta, the particles from these meteoroids flying up 30 kilometers above the surface and raining back down.
Yeah.
Yeah.
Yeah. Well, so I'm interested to hear, both of you have had different careers in space exploration, but you've been in sort of a space career for several years. I was curious to hear how you've seen people's attitudes towards the moon shift over the years, whether it's about, human exploration or robotic exploration or, do you feel like the public has like a different relationship with the moon than we did, 10, 20 years ago? Have you noticed shifts where people are more ready for certain types of science or human exploration or?
What I've noticed is more of a global interest, and maybe because it's come with the access to the moon. People I talk to, I still find are somewhat disinterested with the moon. Been there, done that. I think many of them still don't understand the discoveries we've made in the last 10 years. And you think of it this way, the moon and the water cycle that we know now exists here, that's only happened in the last 10 years. That's not a lot of time, and it takes time for that to actually disseminate and become a popular understanding. I think it's still not quite gotten there yet. I think there's just fundamental transformations within the science community still occurring, and a lot of arguments and a lot of head scratching. We know there's, as Kim mentioned, there's more questions than answers with all these new data we get.
Yeah, you start putting up really modern technology, but in any age, anything is modern. So the recent revisits to the moon in the last decade brought a very different view. And except the time hasn't passed enough for all the interpretations of those questions to flow through the community and flow through the public about, actually, we know probably less about the moon. And we know a lot. We know a lot more than we did, 50 years ago and several hundred years ago. But there's certainly a wealth of information that we still don't know. In fact, I was reading a recent paper about they might be starting to debunk one of the most longstanding, 40 years is longstanding in science, hypothesis about an era in our early solar system called the Late Heavy Bombardment, or the lunar cataclysm, where we had this event, short-lived event, that lots of rocks came and pelted the inner solar system. And this was around the time that the first biology on Earth is forming. Now the interpretation of, we don't really know how long it was, or was it more gradual, not as intense? That has huge ramifications in our understanding of life on our planet. And that's all coming down to looking at whether our analysis of the Apollo rocks had some sort of contamination. Those rocks they were dated, got their age, but they might not have come from the right place where they thought they came from. And by doing that, we don't really have that chronometry. We don't have the time clock that the moon holds. So we really actually do need to revisit how we set the solar system's timeline.
And that point's really important, because that's how we date other planetary surfaces.
Yeah.
So it's not just our system, Earth and the moon, but if we look at Mars and the ages of the surfaces there, or any of the bodies in the inner solar system in particular, the moon is our calendar, is our clock.
It's our calendar clock.
And I love where we're sitting today. Actually, like, this is the Apollo 15 I believe, sort of moonscape, and actually getting to kind of live on the moon right now for this podcast is fantastic, because it's sort of that reminder of how far we went, but as you say, how far we have to go still. Yeah. And what are some things, for example, that we didn't know about the moon 50 or 100 years ago when a film like this was made? What are some things that we couldn't possibly know back then? You
want to start?
Well, one of the things that, when I look at lunar history, I look at 3 time periods. One was before that film was filmed. There's actually several centuries before that, 1609. That was the first time that we looked at the moon with a telescope.
Saw mountains.
And got to see mountains. Yeah. And then from then your imagination goes. And I'm a collector. I have a few astronomy textbooks from the 17th and 18th centuries.
Oh, wow.
And just look at how they describe what's on the moon. And when you had this first leap in lunar science by looking at the moon with a telescope, you got to see craters, you got to see the dark bits. So that happened before the movie, right? But, this era that between then and, Apollo in the 1960s, 1969 through 1972 with the sample return, that's when the modern day interpretation of the moon started. Because prior to that, they had really no clue how the moon formed, what the moon was made out of. Did the moon even have a crust? How similar or different the moon was from the Earth? But using those rocks was so important. And we have our moon rock here. That, the really analysis awesome. That's going on then and till today, is uncovering a whole bunch of these questions. But we were pretty in the dark of what the moon was like prior, to the 1960s. We only had those telescope assets.
And a great example of this from an engineering standpoint is on the Apollo landers, their foot pads are very large, and they were over-designed because there was a real concern by many that the soils of the moon, they knew they were getting churned up by bombardment, by meteoroids, and that it was so fluffy that the entire capsule would sink.
Yeah, like into a big marshmallow or something.
Exactly, right? So they over-designed those foot pads for what we now know were ridiculous conditions. It just doesn't exist. But we had no idea. We only had telescopic and then orbital and then landed.
And a few landed landers. Prior to Apollo, we had the Surveyor, and then the Soviets had the Luna and the Lunokhod programs. Yeah. So it's a little bit influenced, but
that was all early 60s.
Just a few years before. Yeah. And so, in terms of designing things to land on another world, you were shooting in the dark.
Yeah, well, that brings up a good point of what we now know, or at least know enough to prepare humans to return to the moon or live on but be on the moon long term. What are some things that we know that we need to prepare them for about the lunar environment nowadays?
And there's one other key discovery that we've learned, and that's the water. You mentioned that. Right. And hand in hand with that goes the topography. We have such a better understanding of the topography now that we were able to confirm some predictions that came from the 1960s, early 1960s, that there would be floors of craters at the poles of the moon that would be in permanent shadow and therefore very, very cold. And so the new data sets we have from LRO primarily allow us to confirm that. Now we really have an understanding of where the sunlight is and where the shadows are. And that is key to returning, especially now since we're returning to the South Pole of the moon. Mm-hmm. That's where we're headed, and we need to understand those shadows and that light because it's key to designing the landers and how they're going to operate, and we're going there to stay. So this part of the sustainability is using those resources, mainly water and light, as means to supply fuels, provide energy, etc. So those data are really have only been acquired over the last 2 decades, and really a big part of that only after the last decade from the Lunar Reconnaissance Orbiter.
So if we were having this conversation 10 years ago, we would not be talking about water cycle on the moon.
No, we would not.
This was this other leap.
When you say water cycle, what do you exactly mean?
Okay, well, we have a water cycle on the Earth. It rains, and then the rain can evaporate. So you can go from a liquid to a gaseous state. You can also freeze them when we have our winter storms. But things get deposited and then things leave. So on the moon, how did the water get there in the first place? Did it come from the comets and the asteroids? Or did it come from the solar wind bringing hydrogen and then mixing up with other things on the surface of the moon? Or is the water generated from within the moon? One of the interesting discoveries a couple of years ago is reanalyzing the Apollo rocks with modern day instruments that could detect water down to a much finer granularity, and we're able to find water deep inside rocks. That starts giving, there's another source. So when we talk about cycles, you talk about sources and sinks, things where things are collecting and where things go. What are huge questions about? So we found the water. We have extrapolations of where the water would be, where it's preferably located, and depending upon which scientist you ask, it's all over the moon or concentrated at the poles or both, depending upon what flavor, surface, subsurface. We really don't know. But how did it get there? Why is it maintained? Does it change? Is it mobile? Does it move? How is it moved? Is it escaping? That's what I'm meaning by water cycle.
Yeah.
And there's, it's the cycle of water. But we couldn't have this conversation.
Yeah, prior to this, we thought the moon was bone dry.
Yeah.
It was based on the samples.
Yeah.
And there's some instances where people reported higher levels of concentration and they were ignored. They were like, no, the moon's dry. You got it wrong. And so it wasn't really until 10 years ago when L-Cross made the observations, and at the same time there were 3 data sets looking at superficial water that were reported from the Moon Mineralogical Mapper and Cassini data. This is one of the neat things is when the Moon Mineralogical Mapper team saw what they thought was water signature, they couldn't believe it. So they went and they asked a colleague who was working on a Cassini instrument.
The one at Saturn
Yeah,
that
recently, yeah.
plummeted into Saturn.
Exactly. They said, you looked at the moon for calibration with this near-infrared instrument a while back, right? Because a lot of spacecraft use the moon as a calibration source. And he's like, yeah, I did. And they're like, could you look that up and just take a look in this area for us? And he's like, well, you did. And he's like, it was 6 years ago. The data was 6 years old. He brought it back up. He was like, yeah, I see that. That's not water, is it? And it's contamination. Then he went back and convinced himself, no, it wasn't contamination. And then they got a third data set because what's it saying? Extraordinary claims need extraordinary evidence.
Yeah.
So the 3 teams got together and they all showed, there's water at the surface of the moon everywhere. And that was 2009. And since then, more and more data has come in and shown, as Kim described, a very complex system. There's water in different forms, different flavors, concentrations, different places, and we're only now getting a handle on that.
Yeah,
we're only scratching the surface because all this data was all from orbit, with the exception of the L-Cross impactor where we sampled one place.
We literally scratched the surface.
We scratched the surface. We need to be on the surface to do the proper exploration.
Well, what's some future science that you're looking forward to do on the moon to figure things out? What are some questions you're wanting answered still?
Well, with the water story, finding the location and also the depth and whether can you actually connect the orbital data to what you have on the ground. I'm also interested from an astrophysics point of view. I would love us to explore the far side of the moon.
Absolutely.
It's a terra incognita. I mean, terra unexplored. It's unexplored territory. We haven't explored a lot of the near side, the side that we see every day, but the far side is a nice radio quiet zone. And you can actually start to explore the universe at wavelengths that we haven't actually been able to explore the universe at because we've had contamination from our own terrestrial environment.
Yeah.
And just like a couple of years ago when our entire view of the universe changed when gravitational waves were discovered, and even though that's not EM, but it's still a different type of information about the universe, our knowledge of the universe is changing rapidly right before our eyes. Can you imagine if we opened up another region of that, our energy spectrum, by placing telescopes on the far side of the moon, what we would hear. So this is sort of using the moon as a scientific place. There's lots of unanswered questions from the geology and the chronology and all that, but it's also a great place to do science from.
Yeah, so I guess my final question for both of you is, what would you like to see films depict about the moon or getting to the moon that you feel like haven't fully been realized? So, we have A Trip to the Moon from 1902, obviously that has one perspective, but also lately there's been movies like First Man and other movies like Moon, but I feel, maybe they're not showing all aspects that we know about the moon. Like what would you like to see a film try and take a stab at depicting about either the science of the moon or somehow of getting there or how spacecrafts operate with it?
One of the things that is fascinating about the poles of the moon is how dynamic they are. And this is something that I think even people within NASA haven't really fully appreciated until we've recently been tasked to land a man and a woman in a few years at the south pole of the moon. And by dynamic, I mean it's unlike anywhere else on the moon that we visited in terms of lighting, topography. Everything else is so extreme. It is an extreme environment where you can go from 250 degrees Kelvin in the sunlight to 40 Kelvin in the shade within a few hundred meters a walk, and that is extreme. And you can, if you're sitting in one spot, shadows cast by mountains hundreds of kilometers away can stream across you within an hour or two, and your temperature will change. You have electric charging. It's an environment that is unlike anywhere on the moon, and we're going to go visit it and try to live and work in it. I don't think there's been a movie that's ever depicted the polar regions like that on the moon. It's all been kind of Apollo-like.
Yes.
Because you go from what you know. But we could take a lesson from 1902, that movie, where it's more fantastical and you can look at what is possible, but rooted in truth. So you could take advantage of the poles are different and show those extreme environments. And so your astronauts will be dwarfed by crater rims that are tens of kilometers in height, and you're in pure darkness, but there might be this glimpse of light at the rim, this dramatic setting.
Yeah.
And then you're going to try to do something. You might be familiar with The Martian, the Andy Weir novel and the movie, which was awesome because it had a lot of routed into, what the Martian exploration would look like, with a little, fantasy there on how he was going to,
artistic license.
Something like that on the moon hasn't really been made. I think it would be really neat if we had a lunar movie that took a nice homage to the 1902 movie, Trip to the Moon, by going and explore the lava tubes on the moon.
Absolutely.
These underground caverns, and trying to explore that. And it could be, you can even imagine a scene where this future astronaut in this movie is rappelling down into the lava tubes and shining a light and seeing that there's all this amazing geology and rocks and everything that hasn't been explored before, and perhaps even get some glimpses into the water cycle, some new things there, and could make a quip. Back in that 1902, this is not like a trip to the moon. I don't see any mushrooms here. But where are those selenites?
Yeah, watch out for the selenites.
Watch out for the selenites.
Oh,
but then you could probably see that with nice little, you could do things with shadows. Because what's neat about, the moon has no atmosphere. So the edges of the shadows are crisp.
Yeah.
And this was even commented on by the Apollo astronauts who had said, oh my gosh, I can't judge distance very well because of the lighting conditions. So I think a movie about the moon will be very dramatic, mainly because of the lighting conditions.
Yeah,
too.
absolutely. Well, thank you both so much for being on the show today.
Thank you.
Oh, thanks.
Yeah, this was awesome. So I really enjoyed that conversation, just having a bunch of moon scientists here to actually talk about, our history of knowledge and what's changed and what we know and don't know still about the moon. And I'm also really excited because we're literally sitting in front of right now a piece of moon rock from the Apollo 15 mission. It's around the size of a golf ball. And I don't know, what does it look like to you, Norm?
It blows my mind because getting up close to this beautiful display, not only can you see just the weird textures on the surface, but the colors. I could see a little bit of what looks to me like green on there, and I just think of, when I look even the photograph around us, this panorama of the moon, the moon is gray, right? Everyone knows the moon is gray, but it has variations of color, variations of gray, and Apollo 15 brought back, I think, 700 pounds of moon rock. That's, of course, broken down, disseminated to research facilities all over the world, and this golf ball sized chunk in front of us, that's a piece of history.
Yeah, and so our conversation was, I don't know, I really appreciated it, and really appreciated hearing Kimberly talk about sort of our history of knowledge, not just only in the last 50 or 100 years, but over hundreds of years. And I don't know, it's just, there's a lot that we didn't know about the moon, and there's a lot of stuff that we still can learn about the moon, and that's what excites me personally.
And it sounds like that's what excites these scientists here, that we know we're eventually going to want to go back. There's so much yet to explore on the moon, our nearest neighbor, on the other side, other face of the moon that we don't get to see, and that's what's happening in part here at NASA Ames. We have so much more stuff coming from our field trip to this facility here, as well as for future Offworld episodes. For listeners out there, if you want to listen to Offworld as a podcast, I want to remind you that you can always go to test.com/Offworld and subscribe there. If you're watching the video, thank you so much. And thank you to our hosts here at NASA for having us here. We'll have a lot more to come.